Good afternoon, ladies and gentlemen. I'm Theodosia Digalaki, and I am the Technical Product Manager of ERMA FIRST Blue Connect, which is our shore power solution. And today we are going to discuss how shore power contributes to carbon footprint reduction. Now, we all know what the global threat is, the climate change. According to IMO, shipping is responsible for 3% of global greenhouse gases. But CO2, it's not the only problem. Sulfur oxides, nitrogen oxides, and particulate matters are important air pollutants who affect marine life and human life in coastal areas. Several organizations around the globe are taking actions towards it. Alternative maritime power, shore power, is part of the solution. Specifically, California Regulatory Board has set a very high target for emissions reduction at berth, up to 90%. So in this context, vessels who reach a regulated berth must connect to shore power and employ a CARB-approved control emissions strategy plan. So container vessels, reefers, and cruise ships must comply starting from this year, while ro-ros and tankers must comply starting from 2025. The European Union, as we have already discussed, is also promoting shore power as part of the solution. According to alternative fuel infrastructure regulations, tent ports must provide shore power infrastructure for vessels to be connected up to 2030. Also, the Fuel EU has included shore power as a solution, stating that container vessels and passenger vessels must connect to ports starting from 2030. Also, we all know about the revised emissions trading system, which includes the shipping sector, whereby using shore power, vessels while at berth can remain within their emission cap. The IMO regulations, in an effort to promote shore power, has issued operational guidelines for the safe operation of OPS systems. And also, we all know about this huge discussion regarding CII and ECSA. By using shore power, CII can be optimized. So, it's very obvious that alternative maritime power has important benefits. SOx, NOx, PMs are completely eliminated. Carbon footprint can significantly be reduced when shore power is combined with renewable resources as the main power energy, solar energy or wind energy at ports. Also, cold ironing shore power installations can have a positive return on investment according to the electricity rates at ports and also the fuel oil prices. Some other benefits are also, since the auxiliary engines are shut down, the life cycle of the auxiliary engines is, of course, extended, and the maintenance costs are significantly reduced, and the life conditions of the seafarers are getting better since there is no noise on board and vibrations caused by the operation of auxiliary engines. So, what is exactly shore power or alternative maritime power? In simple words, when a vessel reaches berth, it can be directly plugged in the shore's power grid to receive the electrical power that it needs for its operation. So the auxiliary engines are shut down and there is no diesel oil consumption. To establish this kind of connection, we need to have infrastructure on both shore side and vessel side. Now, from the shore side, we need to have a main power source, which it can be a renewable resource like solar energy or wind energy. At the location of the berth, we have an electrical substation, and which is connected through a cabling system. Now, between the shore side and the vessel side, there is an interface that is consisted by a cable management system and high voltage sockets, while at the vessel side, we have a high voltage switchboard rated at 6.6 or 11 kilovolts, a power transformer that transforms power from high voltage to low voltage to be distributed on board, a low voltage switchboard, which is the extension and the connection point to vessels' main switchboard, and a control panel, which is responsible for the control and monitoring of the whole operation. According to the size of the power demand and the types of the vessel, we have different requirements about the equipment that must be installed on board. For example, the cable management system must be installed on board for container vessels, while for other types of vessels must be installed on the shore side. Now, no matter the design and the configuration, what we must bear in mind is that safety is very important. So while we design an AMP installation, we must consider two important factors. First of all, that we are dealing with high voltage installations, and also that crew and equipment safety is extremely significant. So, running a risk assessment and analysis is very important. What we did as a procedure was, first of all, to identify the hazards. Then we identified all the risky situations that would lead to these hazards, and we ran a failure mode and effect analysis. Then we evaluated the risk and applied protective measurements and safeguards. And then we had to reevaluate the residual risk and apply additional measurements if that was necessary. So this procedure enabled us to define any weaknesses of the design and develop a better maintenance plan. So, according to technical regulations such as the IEC 8001 established in 2019, there are some key factors of the protection. First of all, the protection relay. It's a very important device that protects the whole installation from electrical hazards. The interlocks between circuit breakers and earth switches it's also very important. And of course, the design of the earthing and the potential boarding system, and the design of the safety loop, the hardwire safety loop, which connects shore side with vessel side for emergency situations. But getting a step further, what we did, we implemented redundancy of the PLCs for maximum availability. We applied redundancy of the power supplies, and we installed UPS, again for maximum efficiency and availability. We used Profinet as protocol for the communication, because Profinet has embedded self-diagnosis that can be used as safeguards. We also used safety relays for emergency operations. We have additional options for remote monitoring and control, and integration with IoT services so that the operator can generate technical reports and have a better maintenance of the system. So ERMA FIRST Blue Connect can be offered as loose equipment or as a containerized solution, which is fixed, or it can be portable for maximum flexibility If we have low voltage distribution on board, the transformer is also part of our solution, but if that is not the case, we also provide high voltage configurations for high voltage distribution on board. So ERMA FIRST Blue Connect is a reliable, regulatory compliant and flexible solution for shore power. So to conclude, alternative maritime power is a sustainable solution. The technology is here and ready to be used, but never forget that safety must come first. Thank you for your attention.